Welcome everyone to tonight's webinar put on by Energize Wayland. And first, a big thank you to my partner in crime, always Kat, who is going to wave and has done with Steve a tremendous amount to make this happen, and is going to do all the tech stuff. Most of us are living in associate with Wayland, and a pretty good contingent from Framingham. So appreciate the cross-pass posting with a bunch of our other Mass Energize communities that Wayland works with and Mass Energize works with. So thanks, Kat. That's incredibly helpful. We'll end that poll, and I'm going to share my screen. This discussion is brought to us by Energize Wayland, and since most of you live in Wayland, just a brief reminder about who Energize Wayland is. We're a community-based organization in Wayland, much like our colleagues in Natick and in Framingham and Acton and a variety of those Medfield that you saw on the polling list, that are working to engage our fellow neighbors and households to take actions on climate change to help us get to our town goals and to personally make our difference relative to the climate emergency. And we're doing that in a way that providing these kinds of webinars and to give you a way to see what you can do, and importantly, tell us what you want to do and what you have done, so that we can count your actions in our work to achieve our climate goals in each of our towns. So if you are in Wayland and have not yet signed up for Energize Wayland, we ask that you go to energizewayland.org. There'll be a green button here to log in and sign up, to create a profile with your email. And once you've done that, or if you come to the main site, you can just hit the sign up button and it'll take you there too. And then we ask you to take an action, because we are trying to engage 1,500 households in Wayland. And you can see here that we have about over 500 households engaged who've taken a lot of actions, or about halfway to our climate goal right now. And we would ask you to go to the actions page, and you'll see things you can do, including tonight's topic, which is green heating and cooling and learning about heat pumps. And you'll be able to tell us what's on your to-do list or you've done it. And while Steve will provide terrific information tonight, if you forget some of that, we can have a description here of green heating and cooling, steps to take, which here says contact Steve. You can see testimonials from folks in town. And you can also, if you want to learn more about the details technically on heat pumps, we have resources on that too. And you'll see when you have a profile, you'll see your to-do list and what you've done. So we encourage you to go to Energize Wayland, because we want to know what you've done, what's on your list, so that we can continue to reach out to you, particularly as we see new incentives and other programs, and email folks with this kind of action item on their to-do list. So thank you for being part of the Energize Wayland community. And if you're in another community, thank you for being part of that community's efforts to address climate change. So I would just, by way of introduction, to say that we installed the heat pump some years ago, and I am my husband, John, and I work with Steve as our coach, and we would highly recommend him to others. And so I think you're in terrific hands to learn about heat pumps. And if you're in Wayland, to work with Steve as a coach. And if you're in another community, Steve can give you some ideas about how to find resources in that community. So handing it off to Steve.
All right, thanks, Ellen. Hi, everybody. Some housekeeping first. We've heard from Ellen. I'm going to give a presentation. I'm going to try really hard to stick to 20 minutes so that we have two Wayland neighbors lined up to give testimonials. Courtney Connery, who's going to go first. She's got an important task at 7:45, way more important than heat pumps, of getting her kids to bed. So we need to give Courtney a chance to talk before she turns into a pumpkin. And Gottfried Seringer, and another Wayland neighbor. So, and then I want to try to leave plenty of time for Q&A. I would ask during the talk, in order to get through it in 20 minutes, I won't be able to interrupt. Try to note down your questions. My personal preference would be you refrain from putting them in the chat till I've finished speaking, because you may find that I answer your question by the end of the talk, or you hear more from the testimonials. So maybe wait till we're into the testimonials to put questions in chat, and then Kat or Ellen will help me start taking the questions, and we'll go as long. Anybody who wants to can certainly leave it as you please, but I'll go as long as people are wanting to talk, or 8:30, whichever comes sooner. Okay. So green heating and cooling for your home. What you're going to hear, and so let me say that I'm doing this as a volunteer for Energize Wayland and as a volunteer for Heat Smart Alliance, which I co-founded. It grew out of the Heat Smart programs that the Mass Clean Energy Center sponsored, and I started coaching people about 2.5 years ago after I got my own green heating system installed, and then since then I've coached about over 40 neighbors in the Metro West area, and actually a few beyond that, and it's given me a good feel for some of the challenges that homeowners face when they do this, and I will offer volunteer coaching to Wayland neighbors, but keep in mind I'm doing it as a volunteer. I can on average take on about one new case a week, so there's some backlog at this point. So what you'll learn today, green heating and cooling really means heat pumps. I don't lead with heat pumps because heat pumps are a technology, not a solution, but the main benefit is that you reduce your carbon footprint and you keep your home more comfortable. I'm going to explain why converting to heat pumps matters for our climate, and then the more complex question of which type of heat pump may be best for your home. And then, of course, there's how much does it cost, and what the Mass Save program has revised its incentive program for 2022, so we can give you a preview of that, and then what steps to do next. So why heat pumps? Well, in New England, about 30% of energy use is for residential. That doesn't count your car driving, that goes in the transportation bin. And of the residential use, about 60% is for heating and cooling, 15 to 20%, 17% here for hot water. And then there's a few percent for clothes drying. The rest is other use, keeping the lights on, keeping your computers and TVs running, and so forth. So in all, about 80% of the home energy load can be handled by heat pumps. So, in general, the path for decarbonizing a home is to weatherize the home, to insulate it, make it lose heat, as little heat as possible, and the Mass Save program helps with that. And sometimes there are things that go beyond Mass Save that you may have to engage a contractor for and pay for that could be worthwhile. The next step is electrifying, and particularly the eliminating or displacing fossil fuel use for the heating system. That is the primary contributor to the household's greenhouse gas footprint. And then because you're electrifying, you want to shift to renewable sources of electricity, and that could be solar on the roof, but there are other ways of greening your electricity supply. We won't go in, that's its own topic for a separate webinar, but this is the sort of the strategy that we have to do as individual households and as a state. So what's a heat pump? Very simply moves heat or pumps heat from a cooler place to a warmer place. You already are familiar with and probably own a bunch of heat pumps. You all own a refrigerator, perhaps a dehumidifier, air conditioners. They're all, they fit the definition I gave in the first line. They're heat pumps. We just don't call them that. And so they're available for home heating and cooling. I can't emphasize enough that when you put in a heat pump, it also does your cooling. So if you're amongst the small percentage of homes that don't have central air conditioning or efficient air conditioning, then by putting in a heat pump, you're also going to get that part of the solution. They're available for water heating. That's the second most important displacement, for clothes drying and even for pool heating. And the way they work is very roughly, is that they take heat energy from the outdoors. It could be the outdoor air, it could be the ground, and together with some input from electricity, so about 1 unit of electricity, 2 units of heat energy from the air. In the case of ground, it might be 4 or 5 units of heat energy from the ground. The heat pump turns that into heat in your home. It's roughly 3 times more efficient than any other type of heating system in using the input energy. So how much emissions, since that's part of our motivation is reducing greenhouse gas emissions, how much can you reduce it? Well, this is, now keep in mind a typical household might be in the range of 10 to 20 metric tons per year of emissions. That would include the car usage and air travel and so forth. So the heat pump is a pretty big factor, and you can see all the fossil fuels here, and then either ground source or air source heat pumps. And there are 2 sets of bars here. One is for what the grid electricity is today, and about 60% of it comes from burning natural gas, so there are emissions associated with grid electricity. But even factoring that in, you can see that a heat pump reduces the greenhouse gas emissions a lot. And if you get 100% renewable energy, then you have no emissions from the heat pump. So this is why it's the strategy of Massachusetts to convert about half of the households in Massachusetts to heat pumps by 2030, and almost all of them by 2050. So which type of heat pump might be appropriate for your home? And here what I've found is every home is unique. It's a unique story. Well, it depends what your existing heat distribution type is. So you may have on the left side a hydronic system. What you have in the basement or somewhere in your house is a boiler, and you have either hot water baseboards or you have radiators and perhaps radiant floors. And then the other common distribution method is forced air. Then you have something called a furnace in the basement, and you have registers in the walls or in the floor, or sometimes in the ceiling that distribute the hot air, and you have a return vent somewhere, sometimes in each room and sometimes a central return. So I think let's see.
Steve, did you want to do a poll now?
Yeah, I did, but I wanted to mention somehow this slide didn't come up. Let's see. All right, so there are other distribution systems. You may have electric baseboards. There are combinations. I've seen every type of combination. Sometimes there's a hydronic heating system, but then a separate air conditioning system, and the ducting might either be normal size ducting in the ceiling, or it could be what's called high velocity ducting. Those are 2-inch diameter outlets that are usually in the ceiling or in the walls that they blow the air out at high velocity. And there are options for those as well. So let's do a poll now. Let me go off share and ask Kat, I'd like to know which type of heating system you have, whether you have hydronic, forced air, or you're not sure. All right, so we have, this is pretty much what I expected. It's about half and half between hydronic and forced air. And then there are those other ones that are either not sure or probably some mix of things. And those are not too unusual in this area, where most houses have had at least one renovation, and you find all kinds of strange arrangements. So one other, so if you have a hydronic heating system now, the most likely thing is that the ductless mini splits are the main option to consider, and those are single zone systems. That's what they started as in the last 5 years or so. The manufacturers introduced what are called multi-zone systems. A single outdoor unit supports multiple indoor units, and those have quite flexible configurations. The outdoor unit can even connect to compact ducted units or an air handler that supports a central forced air system. So there's quite a bit of, the terminology can be confusing, but in general, with if you have a hydronic system, this is usually the first option. There are what are called air-to-water heat pumps, which may be able to reuse existing baseboards, but at the end of the day, you're gonna, if you want cooling as well, you're gonna end up with something that looks like these wall units anyway. So those are, you know, for special situations in general. Now, if you have forced air distribution, then the easiest thing usually to do is to change your outdoor condenser, your air conditioner, for a heat pump. The heat pump looks a lot like the air conditioner. In fact, you can't tell the difference when you look at them from outside. And you may have one of two setups inside. A common setup is you'll have your existing furnace. On top of that is a coil that would also be changed as part of the conversion to a heat pump. And that's now called by Mass Save a partial home electrification. The other option is to replace this whole stack on the left here with an air handler. This is whole home electrification, and you're now getting 100% of your home's heat from the heat pump. The other option is ground source heat pumps. They can be at parity with the incentives available. They can be at parity with cost, but it's a bit longer process to get those installed, a bit more complex. And those would also provide whole home electrification, and they are the most efficient type of heat pump, again, at the cost of some additional complexity when you install them. So these solutions can reuse existing ducting in many cases, not always, if it's adequately sized, if it's insulated and it's reasonably sealed. The insulation and sealing can be done after the fact. And as I already mentioned, there are other considerations, and as we saw, there were a few people, and rather than get into these individually, I'd be happy to answer questions on those specific situations. I'd be remiss in not mentioning heat pump water heaters, are also known as hybrid water heaters. This is a mainstream technology. If you go to your local Home Depot or Lowe's, you'll see these hybrid water heaters displayed now. Not all, they're installed by plumbers. If you have an electric heater now, the payback for installing a hybrid water heater is pretty fast, 3 to 4 years in energy savings. There are significant rebates for them. This could be a whole another topic for a webinar, so I just want to mention it here. I won't say too much more about heat pump water heaters, but that is also an important part of the statewide strategy for reducing our carbon emissions. How much will it cost? That's what everybody wants to know. Well, the question is, which would you rather spend money on? I mean, it's a pretty easy question to answer. You know, it's to put a shiny new electric car in your driveway is fun. Maybe putting shiny new electric solar cells on your roof is also something your neighbors can see and shows just how green you are. That monster, fossil burning monster in your basement, nobody sees it. But and the thing to remember with heating is it's a necessity in this climate. You can't go without heating. So when you talk about cost, you got to remember, it's just like food, that you got to think about it as a necessity. And the cost has to really be relative to what the alternatives are, not looking at that cost. And I'm going to get in later, because of the cost of heating systems. And by the way, depending on the size of your house, it could end up costing as much as this Tesla. Many cases it's less than that, so I don't want to scare people. But it is a substantial cost. But when your heating system needs replacement, you're comparing it against some cheaper solution for replacing the heating system, not against not getting another heating system. So Mass Save, in recognition of how important heat pumps are to our climate, Mass Save is in the process of rolling out a new rebate program. There's a 15,000 rebate if you install a ground source heat pump. That's a whole home solution. If you put in air source heat pumps, those are the mini ductless or the central ducted heat pumps that I described. That's a $10,000 rebate for doing your whole home. But if you retain the fossil system, which makes sense in many cases, there's still a significant rebate. A typical home requires 3 to 6 tons of capacity, and the rebate per ton is $12.50 per ton. The catch is that you have to also put in some integration between the heat pump and the fossil system so that it automatically switches over when it gets colder below some threshold outdoor temperature. It gets colder, it switches over to the fossil system because it may be cheaper to run the fossil system, not necessarily because the heat pump can't do it. And then all systems are eligible for an interest-free 7-year heat loan for up to $25,000. And in some cases, when you put in a heat pump, you also have to upgrade your electric panel. Prior to this year, the electric panel upgrade was your cost, and that typically costs $2,000 to $3,000. It's now eligible for the heat loan as well. There is a significant federal tax credit. This year, it's 22% on ground source heat pump total cost. And then there's a very small credit of up to $500. And that's a lifetime credit on certain energy efficiency improvements, and air source heat pumps and heat pump water heaters are covered under that. So that's a little kicker. In terms of annual energy cost, and this is with prices probably 3-4 months ago, I haven't redone this. You can see that the air source heat pump is competitive with fuel oil, a little bit less. It's definitely going to save money versus propane, and a lot of money versus electric baseboards. That's the most costly form of heating. However, with current gas prices, it's still somewhat cheaper to heat with gas than heat with an air source heat pump. A ground source heat pump is competitive with all of them. So if, for example, there are still some homes on propane or electric baseboard, yes, there is a payback for the heat pump. If you're on fuel oil, then the payback would be very slow, and you have to look at it more from the point of view of doing the right thing for our climate at possibly no additional costs or even saving a little because of these mass save incentives. All right, so what to do next? Because of the cost of putting in a heat pump, it makes sense to do it when your heating system is aging, over 15 years old. Air conditioners, they get to 15, 20 years old, you should be thinking about doing it. And the key thing here is don't wait till your system fails. This is something you want to plan for. It takes time to get. The installers are all super busy right now. They have long backlogs, so you don't want to wait till the system has failed. You want to start thinking about it if your system is getting older, and contacting installers, having time to evaluate learn about the options, and go back and forth to get the right system installed. So if you are thinking of adding air conditioning to your home, or you have some inefficient air conditioning like window air conditioners, then heat pumps are a great way to do it, and they're going to provide heating and cooling. So there used to be rebates for efficient air conditioners. That's no longer the case. The only way you get a rebate is putting in a heat pump, and that's the right thing to do. If you're planning an addition or major renovation, or certainly a new home, it should be 100% heat pump at this point for all its heating and cooling needs. And then if the water heater is aging, meaning 7 to 10 years old, you ought to be thinking about a new water heater, and that ought to be a hybrid water heater in most cases. So what to do next? Heat Smart Alliance, we have a learn page with links to some of the resources we consider best. That's sort of the one place that I can send you where there's links to some of the other really good information on on the web that's pertinent to Massachusetts. You want to get a free Mass Save home energy assessment and take advantage. Most of the weatherization is either it's paid for 75%, in some cases 100%. So that's a really good deal. And they're going to get more aggressive this year about doing things about insulation. So that's an important step. And then you really have to get quotes from multiple installers, and every home is unique. So each installer has brings some different views to it, and they all offer slightly different equipment. And you have to consider, what equipment's offered, the installer reputation, and cost. It's not about getting the lowest cost proposal in most cases. We're going to start with Courtney Connery, and the first question, I'm going to turn it over to you in a second, Courtney. But I'm actually in Rochester, New York, where it's always cold. I think it's about 10 degrees outside now. How cold is it in Wayland right now, or what's the temperature in Wayland?
Oh, that's a very good question. It
Anybody?
is waiting 5 degrees right now.
All right, so Courtney's going to tell you this, but she's depending 100% on the heat pump, and you look pretty comfortable there in the house. Are you comfortable today?
We are, and I only just turned up 2 of the units over 70 this evening.
Okay.
70 degrees. So we are nice and toasty, and I have 2 small children, and so we're not, keeping it cold in here on purpose at all. We keep it nice and warm and comfortable.
All right. Well, I kind of gave you some, if you're comfortable, sort of telling us a little bit about your home and why you went.
Sure.
Yeah.
Sure. So we have about a 2,000 square foot ranch, as you saw in the picture. It was built in 1953. When we bought the home, the original oil boiler was here in the home, which people who came and serviced it couldn't believe that it was there, and were like, this is incredible. So we knew eventually we were going to be replacing our HVAC system. The house also did not have central air, which was something that we wanted to add. So fairly soon, we've been in the house about 4.5 years. And so fairly soon after we moved in, I started very slowly getting quotes, having different people come out and talk about different heating and cooling options. And probably about a year ago, I reached out to Steve, and he was very helpful in helping my husband and I sort of sort through what these mini split things were and how reliable they were and sort of what was going on. We just sort of felt like all the information we were getting was coming from people who were selling mini split systems. And we sort of wanted to cut through the noise and hear a little bit more about, what was the right thing to do for our unique situation. So Steve was very helpful in that. And it was a good thing that I had done my legwork, because I think we met with you, Steve, via Zoom maybe about a year ago. And then in early March of last year, our oil tank sprung a leak. And so suddenly we were going to have to replace an oil tank immediately, like same day. And instead of spending thousands of dollars to do that, we had done all this research. We were going to put in some mini split systems. We decided instead to pull the trigger and just get rid of oil altogether. And we put in 2 of those sort of double systems that Steve showed you a picture of. So we have 7 heads inside the house, and we actually are we're breaking ground on an addition tomorrow. And so we were able to plan it out with extra room in anticipation of some additions that we have planned for the home. So we have room to grow on our systems. And we were very nervous to sort of go completely on just electric, because many groups that came out told me you have to keep your backup heat source. A heat pump will never be able to efficiently keep your house warm in the wintertime. And so I was really nervous, like losing sleep at night over it. And when we initially did it, obviously the pipes from our hot water baseboards and stuff were, the furnace was cut off, and we were kind of like, well, the pipes are here, and if we ever have to really have something reconnected, we could. But then weirdly, a couple of the people on the crew who were installing our mini split system said, oh, we just converted our whole house and we love it. It's great. We've had it a couple of years. And then actually the contractor we're using for the addition we're starting tomorrow, on one of our Zoom calls in planning, mentioned that he also had recently, within the past year and a half, switched his entire house over to heat pumps, mini split system, and was loving it. So it has been great, and it's very comfortable in the house. It's quiet. It's a much more even heat. We don't have the pockets of cold that we would have prior. Every room can be controlled on its own. So my husband and I can have our room the way we want it. Each of the kids can have their bedrooms on the heating or cooling level that works for them. And we have them all on all the time because it's not that big of a house and there's 4 people living here, and we're an active family, so everybody's using all the spaces. We've been really pleased with it. I have to say, I've been shocked at how happy we've been about how well it cools and how well it heats. So these were put in March. So this is our first like hard winter, and so far it's significantly less money than oil. In the summer, I thought it would, because again, we use the AC. It's not like we probably should keep it, a little warmer in here in the summer, but it was new, so we want to see like how will it work. And it only increased our electric bill in the summertime by $50 to maybe $75 additional a month. And now, like the last electric bill for the month of December probably increased the bill by like $400. But that's as compared, like we're obviously spending no money on oil or anything like that. So I've seen a tremendous cost reduction in what we're spending on our heating and cooling.
Great. Well, thank you, Courtney. I wasn't looking for a testimonial for my help, but I appreciate you hearing that you're comfortable on this really cold day is reassuring. And
yeah, I know. I still, every once in a while, I'm shocked that, gosh, these little machines. I was so worried. You can probably see it's behind me. I was worried about how it would look. Also, I was really, really concerned about the look. And they, as soon as they're up, they disappear really quickly on the wall. And as some of the installers and my husband know, you're going to have heating or cooling of some sort visible, whether it's baseboards, whether it's vents on the ceiling or the floor, like there's something that's visible. And now we're actually starting to take the baseboards out of rooms in the house because we don't need them and we want to get rid of them because they're kind of an eyesore. And so we've been really pleased.
Great. All right. Thank you, Courtney. And
thank you.
Time to get those kids to bed. Thank you so much for joining us today, Courtney. I'll introduce Gottfried Seringer. Gottfried's a case where they had some existing ducting. This is one of the more complicated homes that I've coached, and Gottfried may explain a little bit about that. And they ended up putting in a pair of central ducted heat pumps. They're Bosch heat pumps, and they still have a oil heating system as a backup. So this is what's called partial home electrification. Still really good for our climate. So with that, I'll turn it over to Gottfried and tell us about your installation, Gottfried.
Yeah, hello everybody, and thanks, Steve. And before I forget, a huge thank you to you, actually, Steve. You've been a tremendous help trying to sort all this out when we were thinking about that. And as you said, we have a little complicated setup and some old and some new, and trying to make sense of that all. You were great help and all the resources you provided. So thank you for that. And I can't recommend you more to anybody here on the call if you want to know anything. And I appreciate the backup. I hope you don't get too inundated. Anyway, we live in the Happy Hollow neighborhood in Rice Spring Lane, and have a cape from the 1950s, early, I think it was built in 1950 and 1951. Had an addition about 20 years ago where we put in some considerable new space and etc. But had an old heating system, an old boiler with baseboard heat. And from the time we did the addition about 20 years ago, we had central air that we put in at that time. So because we already had central air, it did make sense to look at sort of that central heating system or central heat pump. The trigger was in the end the old boiler that was about to go. I'm not even sure how old it was. It was from before we had moved in, so it was at least 25, 30 years old. And the AC, as I mentioned, was just about 20 years old, not quite. So with that, we decided to try to make the best of what we could here from a carbon perspective, from a energy usage perspective, and combine those two by trying to put in as an efficient a boiler as we could, along with upgrading the old AC to those heat pumps. So we have I guess a double. We actually have two heat pumps outside that are feeding the one for the upstairs, one's for the downstairs, and that are now heating the house when it's above 35 degrees. And we're doing exactly that, what Steve was talking about before. It's switching back and forth between the old oil-based, water-based heat that's still feeding baseboards, and we have some radiant heat in some other parts when it's below 35 degrees. And when it's above 35 degrees, it switches to the heat pump. And that works, by the way, beautifully. You have no idea that it's happening unless you actually check where the heat's coming from. It's totally seamless. We did this whole thing about a year ago, just a little over a year ago, December of 2020. So we've lived with it now throughout last spring and the summer, and now into this winter. It's been particularly great in those seasons when it's not quite that cold. So it's whatever, 35, 40 degrees, 45. You do want some heat, but you don't need to fire up the main system. Or the oil-based system. I shouldn't say the main system. Always happy when I realize, oh, it's like 37, so we're not using any oil. So and if you think about it, there are actually way more days like that than days like what we have today, where it's very cold. We also had, as a side benefit, in a way, the heat pump almost as a backup. We had a couple times where actually during the whole install where we didn't have where the boiler wasn't quite set up yet, or we actually had a problem with our radiant heat a couple of months ago where that didn't work for a few weeks. And so we just ran the heat pump even when it's below 35, and it was no problem at all. And we kind of had a perfect backup system that way. So altogether, I guess we did look at a bunch of installers. It was a little surprising how hard it was to get sort of the right combination of quotes here. There were some installers that easily just want to sell us another boiler and sort of were trying to tell us, yeah, don't worry about that heat pump thing. And then there were others that might have just had the heat pump, but to get that combination was a little bit pulling teeth. We did end up with a very good firm in the end that we felt like they knew what they were doing, that certainly had a lot of experience with both of that. And they did a great job of putting everything in together in one swoop. It was about, I think they were here for about a week in the end to rip the old stuff out and put all the new stuff in, and now we have everything new. What else was good? So, Steve also mentioned that I can't also recommend more the insulation. We did the insulation upgrade at around the same time. It was a couple of months later. We had the old part of the house, the installation upgraded after we'd done energy audit already a couple of years before that. Yeah, done some other things, like with the solar hot water through another program a couple of years before that. So we trying to do what we could with the old house, but the installation certainly made a difference. That's why it makes it a little hard to compare before and after. We've certainly seen a savings for our oil consumption. I believe went down at least 30%, if not more. But years are different. Obviously, you get the oil delivery, so you never sure exactly what sort of goes into which year. But and then, of course, with Corona, we are technically empty nesters, but all of a sudden we had some kids at home again, working from home for a number of months. So all that kind of changed things a bit. So it makes it a little hard to compare right now. I would say cost-wise, it's at minimum just a wash in terms of electricity versus oil. So how they sort of balance each other out. But in the end, the reason wasn't only cost. I definitely want to make sure sort of we reduce our carbon footprint as much as we possibly can. And then it was, as Steve also said, it's in the end, you have to replace that stuff once in a while, and so from that cycle, it was good timing for us.
How hard it was to run the refrigerant tubing or the piping to the 7 wall units. And I would say in your house, Courtney, you had an open attic, and it's easiest to do when there's a ranch house with an open attic. It is somewhat more complicated with other houses where you don't have that open space. But the refrigerant tubing is quite small, and that's one of the reasons the mini split ductless systems have taken over as the main way of doing adding air conditioning to homes with hydronic heating, is that it's fairly easy to get that tubing through walls, existing walls, and dead spaces and so forth. And then I want to.
Ours is actually not in our attic. Ours is actually,
oh, it's not.
No, one half of the house goes into the basement. There's a branch box in the basement and a closet.
Oh,
and
okay.
it snakes up through the walls.
Okay. Yeah.
And one comes in through our garage and goes in.
Okay.
You can see it exposed on the inside of the garage, but it looks like a black garden hose.
Yeah, they're pretty small.
Yeah.
I would say that, you know, it's different for every home, and what I see is a lot of homes have finished basements, so it's not always possible to use that easy to use the basement space. But where they are, sure, they can put it through the basement, through the attic, on the outside walls with little conduits and so forth. I think I see one question that's relevant to your installation, Gottfried, about why you're switching at 35 degrees. And actually, I think that's because the installer set it up that way. Is that correct?
They did set it up that way and was sort of their recommendation. I might actually play around with that in the coming weeks and months to see if it makes sense to adjust that downwards a little bit.
And Mass Save is currently recommending for starting this year a swap over for, if oil is the backup fuel, a swap over around 15 to 20 degrees. And the installers will come along with that. There's some special, I'm aware for Gottfried's home, the ducting was originally air conditioning ducting, and I don't know how well insulated it is. It's also in cold spaces, so the swap over for Gottfried's case may may not make sense. The 15-degree swap over would make sense where the ducting is well insulated and ideally in a conditioned part of the house, not in unconditioned space, which I don't think is true for some of your ducting.
Yeah, it's for the upstairs, it's in the attic. It is insulated, but I can imagine maybe it's not enough insulated or something, but it does work. And as I said, I might experiment with it. It's easy enough to change. I have run it below just out of necessity before. And really the only thing I noticed is that it seemed like those units obviously work a little harder outside. That's
all right.
The only difference.
Let me take a few more questions here. Julie Stanton asked, if I have an old heat pump already, can I use the ducting inside? I think you mean, can you reuse your existing ducting? And the answer is probably yes, but if it's older ducting, it could possibly benefit from cleaning it. Then that would be an add-on that the installer can, there's sometimes separate companies that will clean the ducting. It's hard to say how much that helps, but if the ducting is 20, 30 years old, it seems to me that's worthwhile. And the second step, there's a technology called Aeroseal, where they can actually seal the ducting from inside. You know, the cost is in the $1,000 to $2,000 range. Again, it's hard to say how much it helps, but seems like something that ought to be worthwhile with the existing ducting. But certainly if the home was already heated with a heat pump, the ducting ought to be adequately sized to replace that with a better heat pump. All right, so Aaron Powers asked, how does whole home heat electrification work with a heat pump work at really cold temperatures like today? Does it include some electric heat? And so you've heard from Courtney Connery. She's got a air source heat pump. There's no electric resistance backup. It's just the heat pump that's providing heat. And as cold as it is today, it's capable of doing it. So that the cold climate, the high performance heat pumps are designed to provide heat. The ductless systems claim to provide heat down to -13. These days we have very, very few hours in New England where it's that cold. So, you know, it's possible to make it through. Maybe the temperature in the house drops a little bit if it was extremely cold, but in a, you know, the typical case where it drops to these lows for a few hours or a day or so, the heat pump is perfectly capable of handling that, and in the case of Courtney's system, handling it for days on end. So it really depends on, and that said, there is also with heat pumps, it's important not to oversize them. When you oversize them, they end up being inefficient when it's warmer out in the 30s and 40s, which is actually most of our heating season now. And so it's a little bit, the installers have to be careful about sizing them just right. It's sort of like Goldilocks and the Three Bears. You don't want it too large or too small. You want that medium size that's just right for the house. And Jeffrey's asked, how insulated are the hoses? Are they warm to the touch? So you're, I think, talking about the refrigerant tubing. The refrigerant tubing comes it's copper tubing that's pre-insulated. With the insulation, the diameter is maybe 2 inches per tube, and you need a supply and a return tube. So it's a pair of tubes that goes to each unit. If you take the insulation off and touch the supply side, yes, you can. It feels warm to the touch. Maybe even like hot water warm, but with the insulation on it, you can't feel the difference between those two tubes. So it's not a fire hazard, if that's a concern. Anne, did I answer your question?
I'm typing a follow-up as we
Okay.
speak. So,
all right. question from Nancy LeBlanc. Does cooling in the summer also dehumidify? So yes, in the any kind of air conditioning will also dehumidify, but I would caution that these things tend not to be, if you put one in your basement, it may not act as well as a dehumidifier. They're slightly different devices, and in my own experience, I put a wall unit in my basement and found that I have to run the dehumidifier. If I just run the wall unit expecting it's going to dehumidify, it ends up overcooling the basement. The basement ended up at very cold in the sun, too cold to be comfortable in the summer. So I wouldn't advise trying to use it purely as a dehumidifier, which is really all I needed in my basement. I didn't really need the cooling down there except on a very few extremely hot days. But in the upstairs part of your house, yes, it will keep it very comfortable and dry. And I find actually in my own home that I like to keep the windows open if it's at all comfortable outside. And then when it starts to get hot and humid, we close the windows and turn on our heat pump, and within a couple hours, the whole home is comfortable and dry. So it works pretty quickly. So the question from Amy Finstein about what if you want to remove oil altogether? Can you proceed without worrying about swapping over? And the answer is yes. You heard from Courtney that she's doing that. She got rid of her oil system and relying totally on the heat pump. With oil these days, it's really not about the cost. It may be more a concern about having a backup on those super cold days. And there it can be in some homes, it can be, especially if it's an older home that's not that well insulated, and not, in some cases it's difficult to really insulate the home well. It's desirable to have the oil system as a backup. If you have a working oil system, hydronic system, and there's no need to replace it, I almost would say, yeah, just keep it running. If you're in a situation like Courtney where the oil system had to be replaced, then you have a decision to make. But if it's a hydronic distribution and oil, then those two systems are pretty much separate systems, and you could put in the heat pump without disrupting the oil system. And then it becomes, if you wanted to take advantage of that new rebate for completely removing the oil, but it's not necessary. And from a cost viewpoint, the heat pump's at about a par with right now with heating with oil. Oil went up this year, so maybe the heat pump even has a cost advantage. Let me see. Can I recommend a coach in the Medfield area? I would love to be able to recommend a coach. We don't, the Heat Smart Alliance, we have about 10 coaches. We don't have one yet in Medfield, but I would ask if you put in we do have some members of the Heat Smart Alliance who are in Medfield, and maybe I can persuade one of them to start coaching. So what I would suggest is put in a request through the Heat Smart Alliance website for a coach, and we'll see if somebody's willing to do it from one of the Medfield residents is willing to do it. There's a question here, if you want to replace a gas-fired steam boiler. Now you say boiler, I think you mean furnace, because you say you have a ducted heat pump system. Now this is from, let's see, from Lisa Gianelli. Lisa, do you have ducting in the home now or not?
We have gas-fired steam from the 1920s. The boiler is about 44 years old. We added central air conditioning within the last 15 years. So we have ductwork. It's just a 2-story house with an air handler in the 3rd floor attic and a condenser outside. We have had a weird problem of stale attic air sometimes coming down through the ducts, and no one seems to understand what the problem might be. We suspect maybe there's a little pinholes in the ducting, or they were not properly sealed. And I'm really hesitant to give up this steam boiler and possibly have attic air permeating the whole house during the heating season, because we don't use AC very often.
Yeah.
But our boiler, I think, has a crack in it, and we're going to have to replace it. And it's going to be a big undertaking, and I'd rather just get rid of it.
Yeah, and again, I want to, so the boiler is feeding radiators or baseboards?
Yes,
Okay.
radiators.
Yeah, you're probably, probably the best option for you is to abandon that, abandon both systems and go with a ductless system that would provide both heating and cooling. The ducting, it sounds like the ducting in your attic needs some work, and it's also in an unconditioned space, so it's less than ideal.
Oh, because it's in the attic.
Yeah. Yeah.
Okay.
Yeah.
Okay.
Yeah. Yeah. So that a ductless system would be the way to go, probably.
Okay, but that means having to find wall space for mini
Yeah.
splits in
Yeah.
each room,
Yeah.
where we don't necessarily have the wall space because of windows and the like. Can a mini split, handle a living room and a sunroom, say? It's not a big house. It's a rather small house.
Yeah. In many cases, you don't need a separate unit in every room. If they're open, if there are wide openings between the spaces, a single unit might be able to handle it. There are also, floor units. There's quite a bit of variety in the configuration. So there are floor units, there are ceiling cassettes. So there's a whole variety of ways of solving those problems.
Interesting, so that you could put them in between the joists between floors, or
Yeah.
Okay.
Now it might be require disrupting some plaster and some repair there.
Okay, thank you.
Yeah. All right. We've passed the 8 o'clock mark, and I think I want to offer that I'm willing to stay on and answer more questions, but if folks, I don't know, Ellen or Kat, is there anything?
Yeah,
I
did want to end with one specific thing to Wayland, if I could. We and this is commercial interruption, but it'll take a minute, and then you can stay on if you want to keep asking Steve questions, which is Wayland, we are taking a variety of climate actions as a town, and one thing in front of the Board of Selectmen is to fund a sustainability manager, which in fact Medfield has done, and Natick has done, many other communities represent, and Framing has done on this call. And there is a petition that we are asking people to sign that would add your name to say that you would like a full-time sustainability manager for Wayland. The Energy Committee's work has saved the town about over $200,000 a year in energy costs, and this is a really important moment for us to act on our climate emergency and get in some more staff help to keep getting energy savings and to be able to offer additional support to residents like Steve does around coaching, so we might be able to support some of that. So the link to that petition is Kat, I put in here, let me just, I think I put it in the chat to you, Kat. Can you just share it?
I'll put it in the chat.
Put in the link, but I'll just say this is what it will look like, and you can explain what it is. Then this was started by a resident. We have 36 people signed up in a couple hours. So we'd like to get to a couple hundred. So it's explained here clearly, and we'll send it out as a follow-up. So we hope that people will support that effort so we can continue to do this kind of great work. And I will just thank Steve for his coaching and his work with Energize Wayland and the Heat Smart Alliance and Mass Energize and a million things, where he's a treasure to Wayland, and we need to stand up more of this kind of resources in more places. I hope you guys leave this session with the feeling that I can probably make this work in my house. There are a lot of different systems, but no matter what the system is, you will be able to get much of your heating and all of your cooling done from electric sources. And that's the answer. And plan in advance, because you don't want to be in an emergency. So I hope I'm happy. We'll let Steve stay on for as long as he has endurance and you guys have questions. And we will, in a follow-up, also send information on how to contact Steve. And you can also contact him with his email by going to energizewayland.org. Look on your actions, green heating, and under steps to take, you get right to Steve. So again, we hope you sign up for that. Thanks very much.
All right, I will stay on and answer a few more questions as they came in. All right, the next one is from Anna Romer. If you had solar panels, could you maintain your heat pump during an electric power outage? So the answer is the solar panels are providing electricity to the grid. I don't think currently, and Ellen or Kat can correct me, the solar, if the grid goes down, I don't think you get any electricity from the solar. I'm not quite sure what
That's
happens.
correct. Yeah, that's correct. Unless you had a battery, a backup, which
Yeah,
are starting to come into currency, but
yeah,
most people's solar systems don't yet have
yeah,
that.
and it's still early days for the backup batteries, and whether they might be able to run the heat pump for a few hours, but I doubt that they would have capacity to run it for a day or more. So they would keep you going for a while. But that said, if you have solar and you're currently have an excess of solar that you're not using, then the heat pump will definitely use that up, and so it will save on your electricity costs to have those credits from the solar production. The next question is about which company heat pumps did you use, and I want to preface my answer here saying don't get, each installer typically deals with one or two brands. The larger installers may do a few more brands of equipment, and I would suggest not getting too locked in on a particular manufacturer's equipment, especially right now. There are supply chain issues. But in the ductless space, Mitsubishi has about 70% of the market in Massachusetts. They're the market leader, but Fujitsu and LG have very good equipment, so I wouldn't hesitate if somebody was thinking about a Fujitsu or an LG system. I think that's good equipment as well. And in the central ducted area, Carrier's got some very good equipment. Bryant is basically, there's actually only a few actual manufacturers. A lot of the brands that you hear about are just they're just brands of manufacturers. So Bryant is an example where their equipment is largely identical to Carrier equipment. It just has a different name on it. And that's good equipment. I've been quite impressed with Bosch has some very good heat pumps on the market. They're particularly good for these partial home electrification. Their efficiency at super low temperatures isn't quite competitive with Carrier, but they have fairly simple control systems that seem to work really well. And they work with third-party thermostats from Honeywell and so forth, whereas some other systems require proprietary thermostats. I quite like the Bosch heat pumps, but there's other good equipment out there. That it should be, there's a New England Energy Partnership, NEEP, NEEP.org, and there's a link from the Heat Smart Alliance website. They maintain a list of heat pumps that are qualified for cold climate use, and I highly recommend confirming before you agree to having an installation that your system is listed on their list. And then it should another way of making sure that it has adequate performance is that it qualifies for the Mass Save rebate. Mass Save has its own list of qualifying heat pumps. Unfortunately, some of the ones on the Mass Save list are not what I would consider cold climate heat pumps, and they wouldn't be on the neep.org list, for example. Sorry, I just lost the chat. Next question was from Brian. What is required for ground source heat pump? Good question, Brian. With ground source heat pumps, they have to have space on the property to bring in a drill rig. The drill rigs are about 40 feet long. And so there has to be at least space to bring that 40-foot rig onto the property to drill wells for the mostly in, I'm told in this area, there is what's called trenching, horizontal piping, but it's rarely used in this area. Most of the installations drill holes. They need about 150 feet of hole depth per ton of heating capacity. So a house that requires 3 tons of capacity requires a 450-foot well to be drilled. And the installers typically will, the companies that do the installation of the heat pump will outsource the drilling to other companies. There's a couple companies that are, they all use for drilling the wells. So there's some additional complexity and disruption to your landscaping. They're gonna, when they bring in that rig, they're gonna be tailings from the well that have to be buried somewhere on the property or carted away. So there's a little bit more complexity there. And if you don't, most of the ground source heat pumps work with forced air systems. So if you don't have existing ducting, it might, you might find that it's cost prohibitive to do ground source because they have to install new ducting, and that can be costly and disruptive inside the house. But if you have the space and you know, there's some advantages to ground source. There's no equipment outdoors, so aesthetically it's quite appealing, and from a service point of view, it's just everything's indoors. So if something goes wrong with it in the wintertime, the technician's working indoors, not outdoors. All the refrigerant is factory sealed in it. Refrigerant itself these days, it's not as bad as it used to be, but the refrigerant itself is a greenhouse gas, and a small percentage of it, if you look at all of the, you know, most, there are some installations that where refrigerant leaks, and that's undesirable, and so that has to be factored in. And it's more likely with the air source heat pumps where they're making a lot of connections between the indoor units and the outdoor units that there's some leakage. With the ground source heat pump, the refrigerant's all self-contained inside the unit. It's factory sealed, so it's like buying a refrigerator or a wall air conditioner. The chance of leakage is much lower. Do I recommend it? When I coach folks, I give a list. I try not to refer it, with installers that I've had some experience with, and I try to give some options, but you know, it's really important to get multiple quotes, in my opinion, from, you know, to talk to several installers to get their ideas, and that it's more time consuming. But yes, if I coach somebody, then I point them, but they may also have referrals from neighbors and so forth, and I encourage them to follow up on those too. You don't want to, it's cost time and money for the installers too to visit your house and write up a quote. So you don't want to go overboard on this. If you get maybe 3 or 4 and get quotes from 2 or 3 of them, then you've done your homework. I think it's not necessary to get quotes from 10 installers. And John Flint, you asked about pros and cons of air source versus ground source. Again, the air, you know, the installation cost for the air source heat pumps tends to be lower, but with the incentives, you can come pretty close between the federal tax credit and the higher incentive from Mass Save this year. The distance between the initial cost of the ground source and the air source heat pumps is not as big as you might think, but the process of getting, there are fewer installers for ground source, so getting their attention, getting them to quote you and figuring out what disruption there is to your landscaping. And then, of course, the federal tax credit, you're not going to be able to claim that till you file your taxes. So if you do the installation in March, you're going to have to float more funds up, over that period of time till you get the tax credit. In terms of efficiency, the ground source heat pumps are more efficient. The ground below 3-4 feet below the surface of the ground, it stays at 55 degrees. And so ground source heat pumps can achieve what are called efficiencies of up to 5 or 6, in practice maybe 4 or 5, versus efficiencies for air source heat pumps in the 2 to 3 range, and a little more than 3 on good days. So what I would ask is, if you're interested in using me as a coach, we have a form on the Heat Smart Alliance website, and just, it's a simple form. You enter your name and email address, and I'll get an email. And right now I've kind of got a backlog, so give me a few days to respond, but I'll put you on that. I'll make sure I don't forget you, and I'll respond, at least know you where you are in the queue. All right, and I think we're all right. So Julia Getcha asked, do you keep the heat pump all the time on the summer? I think you're asking, do you keep it running all the time? Well, you could, but if it's 70 degrees outdoors and your heat pump's running and it's reasonably dry, you're kind of wasting electricity, and so you might, at that point, want to either turn it off or just put it into fan mode to save some energy. As I said, my preference is to have windows open when it's at all comfortable, and I just like the outdoor air and the sounds of the outdoors, and so we turn our system on and off. And there were several weeks this summer where we didn't run at all. We just let the house get a little warm in the afternoons, and it would cool off at night, and we were happy. And then when it got stinking hot, you bet we turned down the system, and we would leave it on for a few days at a time, or I think maybe there was a 1 or 2 week period where it ran all the time. But that's really up to you.
Steve, maybe we can take one last question.
All right.
This one's a good one. The one from Jeanette.
Okay.
Can you say more about integrating between a gas-powered steam heat system and a heat pump system? She has both, but there is no communication between the two. Is it possible after the fact to create a connection?
Yeah, so I need a little clarification when you say you have a ductless mini split, Jeanette?
No, it's I think you call it a central.
Central system.
Yeah, it was put in, it was almost the same of what that other person was saying, that in that 1920s house. That's about the same situation. I had an air conditioning put into this old house. It's almost 100 years old. And so the heat pump is using those ducts that were put in for the air conditioning originally.
I see. Yeah, it depends. You'd have to, I'm actually not sure about that case. You would have to talk to several installers, I think, to see if it's possible. So currently you manually swap between the heat pump and the gas system?
Yes,
Yeah.
it's and I'm retired, so I'm able to go up and down to each thermostat and change it. That's what I kind of did in the winter before it got so cold.
I'm not sure. I can offline, I could suggest some, an installer or two that you could call to ask about it.
Thank
All right.
you.
Have a good,
Bye.
have a good night, everyone, and stay warm.